All right, in this video, we are going to add, subtract, and multiply polynomials. Eventually, we'll be dividing them, but for today, just add, subtract, and multiply. And so first of all, a polynomial is a expression that really just means a sum or difference of many terms. Poly means many, nomial terms. So many terms. And so if you have one term, it's called a monomial. If you have two terms, it's called a binomial. If you have three terms, it's called a trinomial. And usually after that, we just call it a polynomial. Standard form is how we write all of our final answers, and it's from highest exponent to lowest exponent. That's very important. Once you have it in standard form, the degree will be your the exponent of the first term, which would be the highest exponent. The leading coefficient would be the number in front of that term with the highest exponent. We care about the degree and leading coefficient because later in this unit, it's going to help us graph. And so looking at this first example, it's not in the correct order. Our highest exponent is 3. And so we would write the negative 4x cubed first, followed by the x squared, followed by the 7x, followed by the plus 6. That's standard form. Highest exponent to lowest exponent. So we have 3, 2, technically that's 1. Technically this would be x to the 0, but we don't ever write those things. And so this would be your final answer. The degree is 3. And the leading coefficient is negative 4. Degree is 3, leading coefficient is negative 4. Just looking at the exponent and the term in front. Okay, here our highest exponent is a 5, so that would go first. And then we would have the 7x to the 4th. And then we would have the x squared. And if you want to cross them off as you write them, that might help. Then we have the negative 12x, and then we have the negative 3. Okay, and so our degree is 5. Our leading coefficient is 2. Okay, next we're going to add them. And when you add polynomials, you just combine like terms. And so I always collect from highest exponent to lowest, so that way it'll be in standard form for my final answer. And so my highest exponent is x cubed, and there's no other x cubes. And so my first term will be 11x cubed. Next would be x squared, and we have 2x squared minus x squared for 1x squared. Next, we have a negative 2x and a 5x, which would give me 3x. And then last, we have 6 and negative 2, which would give me 4. Okay, and so this would be my final answer. My degree is 3. My leading coefficient is 11. Okay, when you are subtracting polynomials, I always go ahead and distribute this minus sign to each term, which is technically multiplying by negative 1. It changes every sign. Okay, and so just changing the sign of every term. And then we don't need to distribute anything to the first parentheses, so we don't need to write them. And then same thing, combine your like terms. So it looks like my highest exponent is x cubed. There's no other x cubes. And then x squared would be next. We have x squared and negative 9x squared for negative 1x or negative 8x squared. And then x would be next. So negative 6x, that's the only one. And then last, we have negative 8 plus 4, which is negative 4 for the constant. And so looking at our first term, our degree is 3, and our leading coefficient is the -3 that's in front. Okay, and so as far as like adding and subtracting, there's different ways they could ask you to do that. One way is asking you to find the sum, that means add, or they could ask you to find the difference, which means subtract. So if they say find the sum, f of x plus g of x, it's the same thing we just did. So we're gonna add f of x, which is 5x to the 4th plus x squared, plus g of x, which is 7 plus 9x squared minus 2x to the 4th plus x cubed. Okay, and so we would just combine our like terms, highest to lowest. And so the highest exponent is 4. And so 5x to the 4th minus 2x to the 4th is 3x to the 4th. And then we have an x cubed. There's only one. X squared would come next. X squared plus 9x squared, which is 10x squared. And then we don't have an x term, but we do have one constant. So we would put that in the end. So the degree is 4. The leading coefficient is 3. Degree 4, leading coefficient 3. Of course, we're just practicing identifying those. This would still be your answer. Okay, and so for this one, we're finding the difference. Difference means subtract, and it says of 12x squared plus x. And so when they say find the difference of this and that, the first expression should be written first. So 12x squared plus x minus 6 minus 9x squared plus x7 minus 8x. Notice the use of parentheses, because just like that previous example, we do have to distribute that negative to every term. So that would give me -6 plus 9x squared minus x to the 7th plus 8x, just switching the signs of every term. Leaving the first parentheses alone, nothing to distribute, and then you are ready to combine like terms. So x to the 7th is the highest, -x to the 7th. And then the next highest exponent is x squared. There's 2 of them, which would give me 21x squared. And then we have x plus 8x, which is 9x. And then the constant is -6, and that's all we have. And so we have a degree 7 polynomial with a leading coefficient of -1. We don't usually write the 1, so if you just see a negative sign, the 1 stays invisible. All right, so that's adding and subtracting. Now we are going to multiply. And so when we multiply a binomial times a binomial, we use the acronym FOIL for first, outside, inside, last. But essentially every term is getting multiplied by every term. Some even call it double distribution. And so here we have a trinomial multiplied by a 4-term polynomial. Okay, and so it is going to be very helpful to use a box. I know it seems kind of elementary, but I promise you I do this, and it saves you from making a lot of mistakes, and it gives you a good way to check your work. So I write one polynomial along the side. I usually write the one with the less terms. And so those 3 terms for the first polynomial. And then for the polynomial along the top, there's 1, 2, 3, 4 terms, and put them in order, standard form. So 11x cubed, followed by -x squared. 5x should come next, and then the -2. Keep all their signs. Don't lose any negatives. You don't have to write plus signs, but you do need the minus signs because that means the term is negative. Okay, and so I've got 4 columns for each of those 4 terms, and then I have 3 rows for the first polynomial. Okay, so every term gets multiplied by every term. And so when you multiply the coefficients, but you add the exponents. Okay, that's a rule of exponents that we'll get into. So what I say in Algebra 1 is multiply the big numbers, the coefficients, add the little numbers, the exponents. So 11 times 2 is 22. X squared times x cubed would be x to the fifth. Multiply the big numbers, add the little numbers. Here, 2 times -1 is -2. X squared and x squared would be x4. For the next one, we would have the 2 times 5, which is 10. And then x squared times x would be x to the 3. Add the little numbers. And then 2 times -2 is -4. And then you still have the x squared. Okay, next row, multiply your coefficients, add your exponents. So -2 times -1 is 2. X to the first times x squared is x to the third. Next, -2 times -1 is 2. X times x squared is x to the first times x to the third is x to the fourth. Add the exponents. Okay, and then -2 times -1 is 2, and then x times x squared is x cubed. -2 times 5 is -10, x times x is x squared. -2 times -2 is +4, and then we just have 1x. Last row, 6 times 11 is 66, and then we have the x cubed. 6 times -1 is -6, we have the x squared. 6 times 5 is 30, and then we have x to the first, and then 6 times -2 is -12. Now, if you have these in standard form, you should notice that your like terms lie on the diagonal. So we just have one x to the fifth term, so that will be our first. And then next, we have our x to the fourths. Okay, so 2 and -2 x to the fourth. Oh, that should have been a 22. Sorry. -2 times 11 is -22. So we have -22 x to the fourth and -2 x to the fourth. So that would be -24. Combining our like terms, the exponents don't change now. You just combine like terms and keep the exponent. And then along the diagonal, we have 66, 2, and 10 for our x cubes. 66 and 2 is 68, plus 10 is 78. And then we have -6x squared, -10x squared, and then -4. That would be -20x squared. And then we have 30 and 4 for the x term, so 34x. And then we have a -12 at the end. Okay, and so just combining all your like terms, keep the exponent. And so the degree of this polynomial is 5, and then the leading coefficient is 22. Okay, here, when they say product, that means multiply. So we're multiplying x squared minus 8 times this 4-term polynomial. So 3x cubed, 9x squared should come next, 6x, and -4. Put them in order so that your like terms fall in the diagonal. That'll help you find mistakes. That's how I was able to find my mistake with the exponents. Okay, and so 3 times 1 is 3, x squared, and x3 is x to the fifth. Multiply the big numbers, add the little numbers. 9 times 1 is 9, x squared and x squared is x4. 6 times 1 is 6, x squared and x is x cubed. 1 and -4 is -4 with the x squared. Okay, -8 times 3 is -24 with the x cubed. -72 x squared, -48x, and then -8 times -4 is +32. Okay, so here we were missing a term, and so if you're ever missing a term, they're not going to be perfectly on the diagonal, but they'll still be close. And so we have 3x to the fifth, and then we have our 9x to the fourth. There's no other x to the fourth. And then we have -24 and 6, which would be -18 for the x cubed. And then we have -72x squared and -4x squared for a -76x squared. and then nothing else to combine. We have our negative 48x and then our 32. And so this is a degree 5 polynomial, leading coefficient 3. Okay, and so let's jump to this application problem. It says you were trying to create a gift box for a holiday present from an 8 by 12. Okay, and so we'll assume this is the 12 and this is the 8. Okay, sheet of construction paper. You decide to do this by cutting squares of side length x from each of the corners. Okay, and then folding up the remaining sides to form the box without a lid. So this is where you would fold, and so these this would be the side, this would be a side, this would be a side, this would be a side, and this would be the bottom of the box. Write a function v of x in standard form to represent the volume of the box. And so volume is length times width times height. Okay, and so the length of this box would just be this portion right here. Okay, and so the length, the full thing is 12, but we cut x from each side, so that's going to be 12 minus 2x, minusing an x from each side. Okay, likewise for the width, this would be our width, and we're subtracting x from each side, so the original is 8, but we're subtracting x, subtracting 8x, so 8 minus 2x for this dimension. Okay, and then this would be the height. When we stand up these sides by folding, the height would just be x. And so to find the length, we would multiply all of these together. I'm going to put the x first, followed by the binomials. Because this would be a FOIL situation. You could distribute the x first if you wanted to. I just wait and distribute at the end. If you do distribute first, only distribute it to one set of parentheses, not two. You would be multiplying by x twice if you distribute it to both sets. Okay, and so 12 times 8 is 96. And so I don't use a box for FOIL, but anything bigger than a binomial times a binomial, I would. So negative 24x, negative 16x, and then positive 4x squared. And so put the 4x squared first. Combine your like terms. That would be negative 40x. And then our constant is 96. And then lastly, just distribute the x to get 4x cubed minus 40x squared plus 96x. Basically adding 1 to each of these exponents as we multiply that x in there. And so our equation for the volume v of x would be this expression here. Okay, and so going back to these more challenging examples, it says find the product, so that means multiply, of this polynomial times this polynomial. So the red polynomial I just highlighted, we need to do some simplifying first. And so here we have a set of parentheses, that means distribute. So before we do anything, we need to distribute negative 4x squared to get negative 4x cubed. And then negative 4x times negative 5 would be positive 20, and then we still have the x squared. Okay, so anytime you just have a monomial, a single term in front of a parentheses, that's when you distribute. Okay, and then we have the 3x squared here. And so we actually have some like terms we can combine. 3x squared and 20x squared would be 23x squared minus 4x cubed. Okay, and so now we are multiplying this red polynomial, we've simplified it, by the blue. Okay, and so I'm going to write the blue along the top in order. He's already in order. 4x cubed, 2x squared, negative 9x, and 10. And then this binomial, negative 4x cubed, 23x squared. Putting them in order, keeping their signs. And then you can use your box. Okay, and so when you fill in the box, multiply the coefficients, add the exponents. So negative 16x to the 6th, negative 8x to the 5th, positive 36x to the 4th, negative 40x cubed. 23 times 4 would be 80 plus 12, 92, x to the 5th, 46x to the 4th, 23 times 9, negative 9 would be 180 plus 27, 207 with a negative. X squared times x is x cubed. And then 23x squared times 10 is 230 x squared. Combining our like terms, we have 1x to the 6th term, followed by 92x to the 5th minus 8. 92 minus 8 would be 84. 86. I think that's 84. 92 minus 8 is 90 minus 6. So yeah, 84x to the 5th. And then 46 and 36 would be 82 x to the 4th. And then negative 207 with a negative 40 is negative 247 for the x cubed. Remember, when you're combining like terms, don't change the exponents. And then a 230x squared at the end. And so my degree is 6. My leading coefficient is negative 16. Okay, for this last one, we're subtracting red from blue. Okay, so what we're subtracting is what needs to be after the minus sign. Okay, and then I'm going to simplify the blue by distributing first, anytime you see those parentheses. So move this over. And so negative 9 times negative 8 would be 72. X times x would be x squared. Negative 9 times 4 is negative 36 with the x. And we still have the 6 out front. Since that 72 is positive, we're going to put a plus sign. And then there's nothing to combine, but I do want to put it in order. So 72x squared minus 36x, and then 6 is positive plus 6. So that's my new blue, simplified blue polynomial. So subtracting the red from blue, subtracting red from blue. Okay, and so that means we need to distribute the negative to that red polynomial. So negative 12x squared minus x. Nothing to do with the blue. And then now we're ready to combine our like terms. So I have 72x squared, negative 12x squared, which is 60x squared. And then I have a 36x minus x, which is negative 37x, and then a plus 6. And so my final answer is 60x squared minus 37x plus 6. It's a quadratic trinomial. So degree 2, leading coefficient 6. Degree 2, leading coefficient 60.